OK, we're all done with this section. So to quickly summarize, XSS was the first attack we saw. And the idea was that the user would pass in untrusted content, and the server would think that the content is actual data, potentially code. So for example, the user could pass in evanbot, and the resulting web page would say the user input. And if the user instead inputs something like a script tag, if the website isn't careful, it will send this HTML to victim users, and this will be interpreted as code. And this allows the attacker to run code with the origin of the victim website. So the important thing about XSS is that it subverts the same origin policy. The attacker could have sent JavaScript with the origin of evil.com, but instead, by using XSS, now the attacker can send JavaScript with somebody else's origin, which is bad, because now you can access that origin's cookies or secrets. There's two versions of XSS. One is stored XSS. I think of social media websites where you store a post on the database of the server. The other one is reflected XSS. I think of Google search, where you type in a search query, and the URL itself has your query, and it's returned to you when it says how many responses for the query that were found. And reflected XSS has the additional requirement that the victim has to click on a link that has the JavaScript in it, or otherwise make a request with the JavaScript inside, so it gets reflected back to the victim. How do you defend against XSS? We saw sanitization, where we ask some trusted library to escape any special characters. And we also saw content security policy, where the server tells the browser they can only run specific trusted pieces of JavaScript and not just any piece of JavaScript that's on the website. Then we talked about UI attacks. We talked about clickjacking, where you trick the victim into clicking on something unintended. The browser doesn't know if the click was intended or unintended, so the browser has to trust the click, and that could cause something bad to happen. For example, fake download buttons, putting an invisible frame on top of a visible frame. And the way you defend against this is to have the browser itself enforce visual integrity and temporal integrity, so that the user has a better idea of what they're clicking on and confirms when they want to click on something. And finally, we talked about phishing, where you make a website that looks like a legitimate website. And if the user doesn't know any better, they type their secrets into this impersonated website, and those secrets get sent to an attacker. Now, we shouldn't say that phishing is the user's fault, because detecting phishing is hard, especially if you aren't a security expert. So to defend against phishing, we need better schemes like two-factor authentication or security keys. OK, that's it. SQL injection is the next topic.